Okay, so we've now explored integers and floating point numbers. We've stored them in variables, and we've performed some calculations. Now let's take a look at a few more number considerations. Firstly, Python offers a shorthand for updating variables. When you have a number saved in a variable and want to add a number to the current value of the variable, you can use the += operator, which is simply done by putting a plus symbol followed by the equal symbol. So let's say we had a variable called footsteps, which stored the number 500 in it. We then go out for a walk and do another 2000 steps. We can now update the value stored in the footsteps variable by putting the name of the variable, and then plus equals, and then 2000. This will add 2000 to the value already stored in the variable footsteps. When I now print out footsteps, we get 2500 returned. Now we can take this further by adding other arithmetic operators followed by the equal sign. So we currently have 2500 in our variable called footsteps. But let's suppose we miscalculated and we want to deduct 300 from this value. Well, we can do this in two ways. We could firstly perform the calculation, footsteps minus 300, and then reassign the result of this to footsteps, which will override the original value. But despite this getting the right answer, we've had to write out the variable name footsteps twice, so not very efficient. A shortcut to achieve the same result is by putting our variable name that we want to change, in this case it's footsteps, and then putting a minus symbol followed by the equal symbol. When we now print out the result of footsteps, we get 2200 as the result. We can also use the multiply equals. So if we wanted to see how many steps we would do after a week of walking 2200 steps a day, we can put footsteps, which we know currently holds 2200, and then put star equals and then 7. This will change the value stored in the footsteps variable by multiplying the previous value by 7. So we get 15,400 when we look at the value stored in footsteps. And finally, if we wanted to divide the number stored in footsteps by 2, we can use the divide equals operator, and we update the variable value accordingly. So a nice clean way of being able to take a variable value and updating it for simple arithmetic operators. Now there are 3 more operators I want to share with you which come in handy for specific use cases. First up, floor division. Now the arithmetic operator for floor division, or integer division as it's sometimes called, rounds the result down to the nearest whole number. So let's take a simple calculation, 16 divided by 3. When we perform standard division, we get 5.333 recurring, which tells us that 3 goes into 16 5 times, and then we have 1 left over. Now the floor division operator is represented by 2 division signs, or 2 forward slashes. So writing 16//3 will give us 5 as the result, as it's rounding down the result to the nearest whole integer. In other words, just truncating the values after the decimal point. So 69 divided by 12 will give us 5.75. And therefore 69//12 gives us 5 as the result, as it's rounding down to the nearest integer. Secondly, and what is essentially the opposite of the floor division operator, is what is known as the modulus operator. Now in Python, and generally speaking, the modulo or modulus operator refers to the remainder from the division of the first argument to the second. And the modulus operator is done by using the percent symbol. So let's take a simple example. If we perform 16%3, we know that 3 goes into 16 5 times, and we are left with a remainder of 1. Therefore, when we run 16%3, we get 1 as the result. What do you think the answer to 69 modulo 12 will be? Take a moment to think of the answer in your head. When I run the code, I get 9 as the result. This is because 12 goes into 69 5 times, which takes us to 60, and we have 9 as a remainder to take us to 69. Now thirdly, you can also perform exponential calculations by using the double star syntax. So if you wanted to perform 8 to the power of 3, you can put 8 star star 3, and this will bring back the result of 8 multiplied by 8 multiplied by 8, which is 512. So 3 more arithmetic operators for you to digest and store in your calculation toolbox for when they are required. Okay, next up, let's take a brief look at the concept of type conversion. We can convert one type of number into another, and this is also known as coercion. Now look what happens when I carry out the calculation 1, which is an integer, plus 1.0. You can see we get back 2.0, despite the result having 0 decimal places. This is because operations like addition and subtraction coerce integers to floating point numbers automatically if one of the operands, i.e. numbers, is a float. Now we can also change the type of numbers ourselves by using built-in functions like int and float to convert between the types explicitly. So we can turn a floating point number into an integer by placing the floating point number inside the built-in int function. So 2.8 becomes 2 because the 0.8 is chopped off, i.e. it's truncated. We can also turn ints into floats by using the float built-in function. So float 10 will bring us back 10.0. So changing the type of a number can be done explicitly by using the built-in functions int and float and placing the value in the function's parentheses. Or depending on the calculation you are trying to perform, Python may automatically convert from an integer to a float or vice versa, depending on the operation. Okay, great, so we've covered a lot in this video. Just to summarize, you can use the plus equals operator or the same technique with other arithmetic operators to update variable values cleanly. You also have the floor division, which rounds down to the nearest whole number and is represented by a double division sign, so 2 forward slashes. You have the modulo operator, which obtains the remainder of a division and is represented by the % symbol. And you can perform exponential calculations by using the double star syntax. Numbers can be converted between types, in other words they can go from one type, i.e. an integer, to another type, i.e. a floating point number. This is either done automatically by Python or can be explicitly defined in your code by using the built-in Python functions such as int or float.